Hey guys, Miss Megan again with another wilderness survival video. This should be video number 4, I believe. If you guys remember last week, we talked about signaling and I encouraged you guys to go outside and practice signaling. So I hope you guys were able to do that this week and that you had fun. And if you weren't, this week is supposed to be a nice sunny week and maybe you could go out this week and try. Should be fun. So today we're going to talk about compasses. So have you guys ever heard the word cardinal directions before? What do you think that means, cardinal directions? Okay, so cardinal directions are the 4 main points of a compass. So we have north, south, east, and west. And you'll know them because you'll see an N for north, an S for south, an E for east, and a W for west. I've got this picture here for you to kind of show you. So we've got north, south, east, and west. So now you can tell somebody, if you see that, you say, oh, that's cardinal directions. And you can learn a new term. So now that we have that out of the way, let's talk about compasses. Do you guys know what a compass is, or have you ever used a compass before? Compass is a very important thing when it comes to hiking or being outdoors. So we're going to watch a brain pop video to explain a little bit about what compasses are. So let me share my screen with you. We'll get Tim and Moby up here. Okay, Tim and Moby, the mysteries of life.
You have to tell me to duck before you do that. Dear Tim and Moby, how does a compass work? From Henry. Compasses are pretty cool. Pretty much wherever you are on Earth, a compass points north. Compasses can help you navigate. Sailors rely on them all the time. Once you know what direction north is, all the other directions fall into place. Right now, we need to be going northwest. I think we're a little off course. A compass is a really simple tool. It has a small needle made of iron or steel. The needle is actually a magnet with a north pole and a south pole, and it's balanced on a smooth pivot so that it can swing around freely. Wherever the north pole is pointing, that's north. It works because Earth is really a giant magnet. It produces a magnetic field, an invisible area of force that extends all around it. That field makes a compass's needle swing into a north-south position. Hey, good question. With magnets, opposite poles attract and like poles repel each other. So how come the north pole of the compass's needle points north? As it turns out, the Earth's magnetic field is flipped. Magnetic south is in the geographic north, and vice versa. It's not as crazy as it sounds. The compass is a very old invention. It was developed before people had any idea how it really worked. They just knew that one end of the magnetized needle would always point north. So naturally, people began referring to the opposite ends of all magnets as north and south. Really though, they could have called it anything. A and B, plus and minus, whatever. Oh yeah, that's another little wrinkle. The magnetic poles are slightly offset from the geographic poles. That's because Earth's magnetic field doesn't run exactly along its rotational axis. The closer you get to the poles, the more this difference matters. If you're really far north, a compass may actually point you east, west, or even south. But the rest of us can still use a compass to get where we're going. We just have to account for the magnetic variation. That's the difference between a compass needle's north and true or geographic north. Let's see, from here, the variation is about 5 degrees west. In other words, the needle is pointing 5 degrees west of true north. So we just need to adjust our compass 5 degrees to the east. And then adjust our navigation until we're pointing the right way. You're too heavy, and you're not magnetic. You are magnetic? Duck.
Okay, so Tim and Moby told us a lot of things about a compass, but they made one little goof. They said that the compass will point to the North Pole, and that's actually false. The compass points to the magnetic north. So now we're going to watch a video that will explain the difference between the North Pole and the magnetic north a little bit better, and it will teach us a little bit more about how we actually go about using a compass. So let me share with you my next video. And it's a really good informative video.
A compass is part of the 10 essentials, and most people take one with them into the mountains. But how in the world does it work? Luckily, it isn't too hard to use your compass, and when paired with a good map and a bit of know-how, it becomes a powerful tool for navigation. In this video, we're going to cover the essential parts of the compass, how to set up your compass to account for the declination for your region, how to take a bearing from a map to find an object in the field, and how to take a bearing in the field to find yourself on a map. Alright, it's going to be hard to talk about how to use a compass without first understanding what all the different parts are for. So let's go through that real quick. This is the base plate. It's clear, so you can see the map below it. And there's always at least one straight edge that you'll use later for taking bearings. On the side, there are rulers that you can use along with your map scale to help you calculate distance. On top, you'll find a direction of travel arrow to remind you which direction to point the compass when you're taking a bearing. This big circle is the rotating bezel, which is marked with degrees from 0 clockwise up to 360. Above the bezel is a little marker called the index line, which marks where you'll read your bearings. Inside the bezel, the first thing you'll notice is the magnetized needle, which always points to the magnetic North Pole, not the true North Pole. We'll get into the difference in a minute. There's also a big arrow called the orienting arrow, which you'll use to help you orient the bezel. Alongside the orienting arrow are orienting lines that you'll use to help you line up the compass with north on a map. Finally, some compasses have a handy declination scale, which makes it easier to adjust declination. What's declination, you ask? Well, declination is the angle difference between true north and magnetic north. The needle in your compass will only point to magnetic north, so right now it's pointing to somewhere in northern Canada, not Santa's workshop. If you don't adjust your compass to account for the difference between magnetic north and true north, it can really mess up your navigation. Depending on where you are in the country, the declination will be a certain number of degrees to either the west or the east. You can find the direction and number of degrees in the declination diagram near the legend, along with the date of the map's most recent revision. If your map hasn't been revised for several years, it's worth looking up the current declination online. Different compass brands set declination in different ways, and once you know the declination for your region, you can put that information into your compass. When you do, and the needle lines up inside the orienting arrow, the north marker on the bezel will point to true north. This map of the Lake Tahoe area has a declination of 14 degrees east, and it was updated very recently. So we need to move the orienting arrow 14 degrees to the east. Now that the declination is set, you can start using your compass with your map. First off, a bearing describes a direction in terms of degrees. Bearings are way more precise than just saying go east or west. Instead, you can say to get to the lake, follow a bearing of 79 degrees. One of the most common ways to use a bearing is when you're out hiking and you want to head to a specific point, like a peak or your campsite. If you know where you are on a map, it's a simple process. Start by finding your current location on the map. Let's say we're here. Now set your compass on the map so that the straight side of the base plate lines up with your position. Next, find the point you want to head toward. Let's say it's this peak. And rotate the entire compass until it forms a line between your position and your destination. Make sure the direction of travel arrow is pointing in the direction of the peak. Once the compass is in position, rotate the bezel until the orienting lines are lined up with north and south on the map. You can use the edge of the map to help you get the lines positioned just right. Remember to make sure that the north marker on the bezel is pointing to north on the map and not south. Okay, once the orienting lines are running north-south, look at the index line to read the bearing you've just captured. Here, it's 188. Congrats! Now you can use the compass to follow the bearing. Hold the compass in front of you with the direction of travel arrow pointing away from you. Now rotate your whole body until the north side of the magnetized needle is inside the orienting arrow. If it helps, you can remember red in the shed. Once you've got red in the shed, you're facing the bearing of 188 and your destination. If you're out hiking and you want to find your location on a map, you can also take a bearing off a landmark near you. Then you can transfer that bearing to your map and figure out where you are. Start by finding a landmark that you can also identify on your map. Hold your compass up with the direction of travel arrow pointing away from you and directly at the landmark. Now keep the compass flat and rotate the bezel until the magnetized needle is inside the orienting arrow, or red is in the shed. Once the needle is in, you've captured the bearing. A compass with a sighting mirror makes it easy to take very accurate bearings. Hold the compass at eye level and point it at the object. Then tilt the mirror until you can see straight down into the bezel. This way you can see the object and the bezel at the same time. Once you've got the bearing, you can transfer it to the map. Lay your compass on the map and line up its edge with a known landmark. Make sure that the direction of travel arrow is pointing in the direction of the landmark. With the edge of the compass lined up against the object, rotate the entire base plate until the orienting lines are running north-south and the north marker on the bezel is pointing to north on the map. Once you've finished, you can draw a line on the map along the edge of your compass. You are somewhere along this line. If you want to find your exact position, you use a process called triangulation. All you have to do is take another bearing, but with a different object that's at least 60 degrees away from the first. Where the two lines intersect is your position. If you take a third bearing, you'll end up with a little triangle, and the smaller the triangle, the more accurate the reading. Compass skills can be daunting at first, but they get way easier with practice. Watch the video a few times to get familiar with the techniques, and then test them out on your favorite trail. And for more practice and a deeper dive into navigation, click here to find a navigation class near you.
Okay, that video was really good. It gave so much information. You might be kind of confused right now. So if you need to, you can pause this and rewind and watch it again, or maybe even again. And you can practice with your compass and maybe watch it a couple times throughout the week. It can get confusing, like she said. It can be daunting at first, but the more you practice, the easier it will get. So I want to show you my compass. Now, because I couldn't go to the store and get an orienting compass, I have a compass on my phone. Let me find it. There we go. Compass. So here's what my compass looks like. And this might be the easiest way for you guys to practice with the compass. You could always ask your parents if they could maybe download the compass app onto their phone, maybe onto an iPad or maybe a Kindle. I think you might be able to get it for a Kindle. Maybe you already have a real compass and you can go out there. So let's see if you can see this. What do you notice about this compass? Here's our cardinal directions. We've got north right there and south right there, west and east. which is a little bit different because look, see how it moves? So now my phone's pointing to the north, right there. So I'm really facing south right now. So, and this tells you the degrees. So my phone's at 260 degrees west right now. It will also tell you the elevation down here. It tells you a lot of things. So if you don't have an orienting compass at your house, you could download this compass app, and then you could go outside and you could practice with it this week. That's what I want to challenge you to do. I want you to rewind this video, watch that how-to compass video again, and then I want you to go outside with your parents' permission, and I want you to practice with this. I want you to see if you can face north, then I want you to face east, south, and west, and try to find that. And then maybe you could get out a map. That's why we learned about maps before we learned about compasses, because they kind of can go hand in hand. And you could maybe practice some of those things that video taught you on the map. And then you can always let me know how that's going. We went through kind of a lot today, not very much for me, but just watching videos. Just wanted to look over and make sure I gave you all the information that I wanted you to know. So when you are practicing with your compass this week, I want you to find the magnetic needle on your compass, the orienting arrow, the direction of travel arrow, the rotating housing, and the base plate. If you have an orienting compass, get those things out and practice with those. You can practice with it on your phone, practicing the cardinal directions, and just have fun with it. That's the only way you learn, is just by practice. Practice makes perfect. So watch that video as many times as you need. Practice this, play with it. You could always ask your parents if you need a little help from them, and just have fun this week. So I am all done with this lesson. I want you to know that all the teachers love you guys. We miss you guys. We can't wait till we can all be together again, and we're hoping that you're staying safe and healthy. See you next time.